Hello, my name is Peter Jermain. Today is May 30th, 2020, and I'm going to be recording a video for the University of New England anatomy course, and the topic is the integumentary system. I'm going to use a sheet of notes to help keep me on track, which you can see here. The integumentary system is composed of the cutaneous membrane, or the skin, which includes two layers, the epidermis and the dermis. And it's also composed of several accessory structures, including hair follicles, exocrine glands, and the nails. The integumentary system has a diverse anatomical structure and functions to protect us from the surrounding environment. Sensory receptors embedded in the integumentary system provide data about the environment around us. And the system also functions to help regulate thermal body temperature. In terms of the different layers of skin, the epidermis is a stratified squamous epithelium that's divided into 4 layers in thin skin and 5 layers in thick skin. The deepest layer is the stratum basale, where division of new cells occurs. Above that is the stratum spinosum. Above that is the stratum granulosum. Above that is the stratum lucidum, which exists in thick skin, such as that found on the palm of your hands or the soles of your feet. And the superficial most layer is the stratum corneum, which contains dead keratinized cells. The dermis is composed of the superficial papillary layer and the deep reticular dermis, which contains collagen and elastin fibers. And below that is the hypodermis, or subcutaneous layer, also known as the superficial fascia, which stabilizes the skin against the underlying organs. In terms of a clinical application of skin anatomy to my future career, currently one of my research focuses is the development of image-guided intervention techniques for dermatologic surgery. So the motivation for that project is that skin cancer is the most common malignancy in the United States, and the most common treatment option is surgery to remove the problematic lesion. Skin cancer surgery has 2 goals. One, of course, is to completely remove the cancer, and the other is to simultaneously preserve the maximum amount of healthy skin. And this can be challenging for the surgeon because oftentimes the visual contrast of cancer in the skin is very subtle. So it's difficult to differentiate the malignant versus the normal skin visually. And what we know from this chapter is that the reticular dermis contains collagen, which is the main structural protein found in the skin. And as non-melanoma skin cancers grow, they physically interrupt the matrix of dermal collagen fibers. And they also secrete metalloprotease enzymes, which further degrade the protein structure. Our hypothesis is that by imaging disruptions in the collagen structure caused by skin cancers, we can map the skin cancers prior to surgery, and that this would help the surgeon to completely remove the cancer and preserve the normal skin. So far for this project, we've imaged and analyzed 53 non-melanoma skin cancer lesions. And what we're doing is comparing the accuracy of tumor boundary assessments performed by our optical imaging system versus those from the surgeon. And the encouraging preliminary results that we have showed that the diagnostic accuracy of the imaging was 98%, whereas the accuracy of the surgeon was 75%. And these results were recently published in the Journal of Investigative Dermatology. So that's going to conclude this video. Thank you very much for your attention.